3 into 3 into 3 into 3 into 3. We are multiplying 3 5 times. Okay. A into A into A into A into A into A. We are multiplying A 6 times. Oh my God. It's so time consuming, isn't it? It's so time consuming to write the same number again and again in multiplication. Do we have any shortcut for this? Yes, we do have. And we are going to discuss about the same in this video. Hi, I am Vrushali and you are watching Vrusharaj Classes YouTube channel. So in this video, we are going to learn about the shortcut method of writing the multiplication of the same number. Means if same number is repeated more number of times, and this concept is called as exponents. Yes, so in this video we are going to learn all about exponents. So first of all, what is exponent? Exponent is the shortcut way of expressing this repeated multiplication of the same term. Means what? Here 3 we are multiplying 5 times. So how can we express this in shortcut way? We can write this as 3 to the power of 5. Yes, we read it as 3 to the power of 5. Now here in the second example, A we are multiplying 6 times. So the same thing we can write this as A to the power of 6. The meaning is we are multiplying A 6 times. So in general, how we write this exponent? In general, this exponent is expressed as A to the power of n, where this A is called as base. Base means the term which is multiplied. Okay. It can be any algebraic term, it can be rational number, it can be whole number, it can be natural number, it can be integer, it can be anything. Any term, when it is multiplied more number of times, we express this in this form, that is A to the power of n. This is the general form, where A is called as base. This n, okay, this n is called as either power, it is also called as exponent, and it is also called as index. You can call it anything, power, exponent or index. So now in general, if I write x to the power of 4, now the meaning of this is x is multiplied 4 times. If I write 1 upon 2 to the power of 8, means 1 upon 2 is multiplied 8 times. So hope the meaning of this exponent is quite clear to you. It is nothing but a shortcut way of expressing this long way multiplication. This is called as expanded form. Okay, means when we write it in the actual form, the actual number when it is multiplied 4 times, 5 times, when we write it actually 4 times, 5 times, this is called as expanded form. And when we write it in the shortcut way, this shortcut way is called as exponential form. So in exam, they may give you this expanded form and ask you to write in the exponential form, or they may give you the exponential form and ask you to write in the expanded form. Means suppose x to the power of 4, write it in the expanded form. So the expanded form of this is x into x into x into x. X we are multiplying 4 times. Okay. I'll make it still clear to you with the help of 2 examples. So now to solve the sums of the exponent, there are few laws. Yes, now again laws are nothing but the shortcut which makes our exponent sum easier. Yes, laws are not at all difficult. Our laws, then identities, actually these are the shortcut methods of solving the sums. So even in this exponent, laws helps us to reduce this step, to save our time. It helps us to make this sum simple. Now the first law. The first law of exponent is a to the power of m into a to the power of n is a to the power of m plus n. A to the power of m plus n. Now what is the meaning of this? See, base is same here, right? Base is same. 7 to the power of 5 into 7 to the power of 4. Means here in first case 7 is multiplied 5 times. In second case 7 is multiplied 4 times. So the answer is 7 to the power of 5 plus 4, which is nothing but 7 to the power of 9. Okay, this is one simple example. Now if this sum is something like this, 2 to the power of 3 into 3 to the power of 4 into 2 to the power of 6 into 3 to the power of 8. Here we have 2 and 3 as the base number. Means 2 to the power of 3 and here we have 2 to the power of 6. 3 to the power of 4, here we have 3 to the power of 8. So how to use this first law in such case? It's quite simple. It's 2 to the power of 3 and 2 to the power of 6. And the next thing is 3 to the power of 4, 3 to the power of 8. Fine. So this is nothing but 2 to the power of 3 plus 6 into 3 to the power of 4 plus 8, and our final answer is 2 to the power of 9 into 3 to the power of 12. So this law we have to apply when we multiply the exponents with the same base. So in such case our first law helps us. Okay, what about division? Our second law is going to help us in division sums. So now let's check what is our second law. Second law of exponent is a to the power of m upon a to the power of n is a to the power of m minus n. But when we are supposed to use this, when m is greater than n. And what about if n is greater than m? Now, if n is greater than m, this law becomes like this. This we have to apply when n is greater than m. Example, y to the power of 6 upon y to the power of 2. Now here the power of the numerator term is greater. Means our m is greater here. So how we have to solve this? Y to the power of 6 minus 2, which is y to the power of 4. Now, if it is something like this, x to the power of 8 upon x to the power of 10. Now in this case, our n is greater. So the answer for this is 1 upon x to the power of 10 minus 8, which is 1 upon x to the power of 2. Now, with the help of this second law, we can derive one more simple concept. What it is, I will tell you. Okay, now let's check one example. B to the power of 4 upon b to the power of 7. Okay, now if we apply our second law, okay, if we straightway apply our second law, it is b to the power of 7 minus 4, which is 1 upon b to the power of 3. Fine. Now suppose if we solve this sum like this, b to the power of 4 upon b to the power of 7. Now, okay, though 4 is less than 7, we will shift this 7 to the numerator, means 4 minus 7. So what we get here? B to the power of minus 3. And our actual answer is 1 upon b to the power of 3. So from this, what can we conclude? From this we conclude that a to the power of minus m is nothing but 1 upon a to the power of plus m. And also 1 upon a to the power of minus m is equal to a to the power of m. This helps us a lot when we solve the sums of exponents. Yes, when we actually solve the sums, these things helps us a lot. So, when the numerator term goes to the denominator, the sign changes. Means minus becomes plus, and when denominator sign goes to the numerator, even in this case, minus becomes plus. Even the exactly opposite of this is applicable. How? Suppose if it is a to the power of m, this is 1 upon a to the power of minus m. And if it is 1 upon a to the power of m, this is nothing but a to the power of minus m. So, this is the extension of second law. Yes, we call it as extension of second law. Now, let's see what is our third law. Altogether we have 5 laws. Yes, altogether we have 5 laws of exponents. So, this was all about the second law. Let's check what is the third law. Third law is quite simple. A to the power of m to the power of n is nothing but a to the power of m into n, means mn. It's so simple. Means 4 to the power of 3 to the power of 2. This is nothing but 4 to the power of 3 into 2, which is 4 to the power of 6. That's it. This is all about the third law. Now, fourth law. Fourth law of exponent is a into b to the power of m is a to the power of m into b to the power of m. It's quite easy. Means here, if it is 3 into 5 to the power of 4, the meaning of this is it is equal to 3 to the power of 4 into 5 to the power of 4. Let's see actually how and where we use this third law. Somewhere while actually solving the sum, we need to split the terms. How? Now suppose if it is 6 to the power of 2. Okay, 6 to the power of 2. We split this 6 as 2 into 3 to the power of 2, and this means this 2 is applicable to this 2 as well as to this 3. So this is how we actually use this law while solving the sums. Yes, I'll be explaining how to actually apply these laws while solving the sums of exponents. Yes, definitely I'll explain this with 4 examples. Now, the last and fifth law of exponent is a upon b to the power of m, which is equal to a to the power of m upon b to the power of m. Example, simple example, 4 upon 7 to the power of 5, it is 4 to the power of 5 upon 7 to the power of 5. So, this was all about the 5 laws of exponents. Okay, now we have studied 5 laws of exponent. Our first law, a to the power of m into a to the power of n is equal to a to the power of m plus n. Second law, a to the power of m upon a to the power of n is equal to a to the power of m minus n if m is greater than n. And it is equal to 1 upon a to the power of n minus m if n is greater than m. Third law is a to the power of m to the power of n, which is equal to a to the power of m n. Fourth law, a into b bracket to the power of m. Here m is applicable for a as well as b, that is a to the power of m into b to the power of m. Fifth law, a upon b to the power of m is equal to a to the power of m upon b to the power of m. So this was all about the 5 laws of exponents. And as I said, I'll explain how to apply these laws while solving the sums. So this we will continue in our next video. Yes, I'll explain few examples where it will be quite clear to you how actually we use this law while dealing the problems of exponents. So to get the update of our next video, please do subscribe our channel. Yes, do subscribe our channel so that you will get the regular updates of such useful and important videos. And please do share this video among your friends. My dear students, thank you so much for watching this video.